Hi everyone, welcome to the monthly webinar from Timeplus. I'm your host, Jove, head of product at Timeplus, and we also have Ken and Michael. Today's session we're glad to have Michael to join this special webinar to share more about how he built the ServiceRadar as open source project to do the network monitoring using Timeplus Proton. And Ken will share related features such as OpenTelemetry integration and how Timeplus can solve the challenges as well as the upcoming new features of Timeplus. And if you have any questions, feel free to ask in the Zoom or in the LinkedIn, and we'll answer in the end. So if you are new to Timeplus, Timeplus is a streaming-first real-time data platform, and you can build data pipelines to move data from OLTP, from Kafka, and many other systems, and process it using either SQL or JavaScript or Python, and send the transformed data to OLAP, Data Warehouse, Splunk, Datadog, S3, or Iceberg. Or you can also trigger alerts or drive AI or BI. And we offer a similar feature as Apache Flink or Spark, but since the core engine is written in C++, so there's no JVM, there's no other dependencies, so our engine can run much faster and then require less CPU or memory compared to those Java-based solutions. And the Timeplus Proton is our open source core engine, and thank you for the great support since we open sourced it 1.5 years ago. And we get a lot of downloads. We have from different countries, different organizations, and we released more than 50 versions over the years. And we are almost getting 2,000 GitHub star. So if you are on GitHub, please give a star to bookmark it, and you will get the updates. And Timeplus Proton is under the Apache 2.0 license, and it's feature-rich. You can connect it to Apache Spark, Apache Kafka, Pulsar, and do the data transformation and send this to ClearHouse. We also have a very sophisticated streaming processing capability to handle those watermark, the late event. You can apply thousands of SQL functions, or you can write your own SQL functions in your own language, in your preferred logic. And we also have this materialized view. Compared to other materialized view in other systems, this is incremental and streaming based. So compared to ClearHouse, our materialized view can join data from different sources and trigger data, not just on the data insert, but also on the time basis. We probably is the first open source engine that supports Iceberg write. So you may know ClearHouse or DuckDB, they also support Iceberg, but today they are only read-only, right? So we have a pull request open on the Timeplus Proton, and this already ready in Timeplus Enterprise that you can read from Kafka to the processing and send the data to Iceberg and leverage different engine to query them. There's so many features in Timeplus Proton, and compared to other alternatives, it's much faster and efficient. That's why we get a lot of support and use cases in different domains and from different countries. For example, Vivicode and Monosources, they leverage Timeplus Proton to analyze the trading data and find out the real-time insights. Other company, they can leverage Timeplus to apply analysis on the edge with low latency and in massive scale. And on the network monitoring side, ServiceRadar, our special guest today, is also a good example that is Timeplus can get data, no matter it's time series data or some other data or logs or metrics, and provide a very efficient way for you to store, process, send the data to other systems. Michael Freeman is our special guest, and maybe I can, I can hand over to Michael for him to do a self-intro and share more about how he built this next-gen network monitoring system, leverage Timeplus Proton. Michael?
Yeah, sure. Thanks. My name is Mike. I've been developing in the open source world for maybe 20 years now, specialized in network management systems and monitoring systems. So we built ServiceRadar. ServiceRadar is an open source network management and observability platform. It was designed to be secure, easy to use, scalable, and ready for the cloud. We created ServiceRadar because we couldn't find any other network management platform on the market that met our security requirements, worked well on the edge or constrained environments, and didn't cost an arm or a leg. Our choices were either stick with 20-year-old software and deploying that into our networks and hoping for the best, spend a bunch of money on something, or build something new. So we only really had one choice, it seemed like. Security shouldn't be optional, right? We started with setting our first principles for this project entirely around security. We chose secure languages, transparent and open development processes, and build pipelines, and robust security checks have been added throughout the entire system. So we did this by building on a cloud-native architecture backed by a strong foundation with Rust and Golang-based microservices. We've got a one-way data flow that pushes data from the edge to the cloud. Our microservices are secured using mutual TLS certificates where we can do RBAC authorization controls with defined levels of trust. We built our own ServiceRadar query language to interface with the most advanced streaming analytics platform in the industry, Timeplus, leading the way across any open source or commercial offerings already. So cloud deployments benefit from our use of a distributed key value store where we can operate our entire fleet of microservices and create automations. With ServiceRadar, you can monitor any size network. We operate at cloud scale. We can be used to monitor network equipment using traditional network management protocols and the latest streaming telemetry. ServiceRadar users can easily create business value dashboards or get down to the service level using our robust query engine. To highlight some of the features and capabilities, our software is secure by design. It's built on a modern software stack. Timeplus and our ServiceRadar query language and query engine provide streaming analytics. Our one-way data flow helps manage risk and blast radius. And the use of NAT's Jetstream gives us the ability to scale out infinitely. So we recently deployed ServiceRadar at a major airline in the United States. And of course, we had to go through a very rigorous security review process. We passed all of that with flying colors. This is a view of our architecture diagram showing our data flow and how Timeplus fits in here.
That's awesome. So all the data on your lab demo is stored in Timeplus and leverage your special DSL to query it. I guess, yeah, looking forward to learn more about that.
Yeah, sure. Yeah, so all of the data goes into Timeplus, and that's where it lives. Out of Timeplus, we create materialized views from our data streams, and that's what we kind of give you in the UI. We can give you the streaming view or the table view. That's kind of like the nice thing about Timeplus that we really like is that you can treat it like a normal database, or you've got the streaming OLAP capabilities right there. So we were able to replace our primary database with this, and it's kind of like a one-stop shop for us. So we really like that.
May I ask, before Timeplus, which database you use in your system?
Yeah, so we built this. We wanted something lightweight, and the most lightweight solution out there was SQLite, and that worked really well. But of course, it's not distributed, and we quickly realized that wasn't gonna work for us. So we dropped SQLite and replaced everything with Timeplus pretty easily. Wasn't a big deal. Wasn't heavy lift.
Yeah, awesome. Yeah, so yeah, it's yeah, we know there's a lot of customers they try other systems such as Clearhouse and they move to Timeplus. And you mentioned SQLite. Yeah, it might be okay for like transactional or TP workload, but if you have more data, SQLite might facing some challenges, right? It's file based stuff like that. But yeah, also you mentioned Timeplus Proton, not just doing the batch query, but also provide the streaming. So I guess step by step, you might leverage those streaming capability in your system. Yeah.
Yeah, definitely. So yeah, again, it just kind of checked a bunch of boxes for us where we didn't want to throw in a bunch of different tools or a huge Kafka cluster and KSQL and all that stuff. So we've got kind of one binary that we can put on the edge and also push data from the edge to the cloud. So that's our model. We'll eventually probably move stuff off of Timeplus onto a full ClickHouse instance. And if customers kind of need that's a pretty easy move off of Timeplus. I wouldn't consider it a move. It's an addition, right? It's like we're not replacing it. So
Yeah, totally. It's up to the user, right? No matter using Timeplus Proton or enterprise of Timeplus, if they prefer using existing warehouse deployment for their AI, BI, OLAP workload, I mean, feel free to do so, but Timeplus can help them to set up a better data pipeline to put those high quality data in ClickHouse, right? So you don't have to handle so many ETL or data pipeline in ClickHouse. ClickHouse is just for the serving layer, which is doing his job very well.
Yeah, exactly. And the ability to push out that data processing to the edge and even into a customer's network where they can kind of get some of that, pay for some of that compute cost themselves. Like that's awesome. So that's kind of what we're trying to take advantage of too.
Cool. Yeah, sorry for the interruption. Yeah, I guess you might have a few more screen or demo to
Yeah, it's
share.
okay. Well, yeah, quick demo. So this is the dashboard that you see when you log into the ServiceRadar interface. This is kind of like a read-only interface. We designed it so if someone got in here, like you can't move laterally through the system, right? So there's no admin interface. Everything's done through the through the config or KV, and that's sort of like the kind of cloud native approach that people seem to want to use to configure their systems, right? API driven. So we get into the Polar view. The Polars, we've got one of these running on all these different systems. These are all kind of Proxmox PV hosts. The Polar and Agent are a lightweight process that run on there, and they communicate to the checkers. And the checkers are, it's our plugin system. Everything's written is gRPC based and secured by MTLS, so it's easy to write your own checker. You could stand up a checker, in hours or less maybe. And we ship with a bunch of checkers that we've created. We've got a popular network sweep. It's kind of like Nmap. Customers use this to surveil their network, and you can kind of set this up so it runs at a pretty frequent interval without destroying your network. And this gives you pretty good visibility into what's on my network. Is there something new? Is there like a rogue device or something like that? So we've built a bunch of other collectors kind of in the same vein. We have your SNMP Polar collector. We've got rperf. This is Rust-based, kind of iperf3 style bandwidth check. This is great if you want to make sure your e-commerce site always has enough bandwidth available to serve requests, stuff like that. So, I've kind of got it at a low target here. You could set this higher. Kind of have to be careful. You don't want to DOS your network or anything like that. And then we've got our so a lot of our collectors can kind of work where they're reaching out to devices, or we can put an agent on a device. So here's an example of agent-based collection. This is like sysinfo style collection of metrics off of servers. And so all this data is, getting pulled from the checker, agent, Polar up into the core and into Timeplus for analytics and processing.
Yeah, that's awesome. I mean, every page looks rendered so fast. It's more like static image, right? There's no delay at all, right? So it's I guess it's truly a proof that how efficient in-car system is, including Timeplus.
This is awesome.
Yeah. Thank you. Yeah, we just kind of like, when you start from scratch and you build on all new stuff and Timeplus and all these other great technologies, not that hard to build this kind of stuff, which is cool, and really why we did it.
I think, by the way, that is Michael. I think you joined our community Slack or the community over like long time ago, like 2-3 years ago. Even we were at a very early stage. Thank you for the great support as always. And you mentioned you just recently tried to replace the database or replace some engine in Timeplus. Is that something like 1 month ago, or I mean, what's the effort to integrate?
What was the timeline? Yeah. Honestly, it was like a week, really.
Okay.
like to test and everything, or maybe our queries didn't change too much, right? Like it's SQL. We weren't doing, we can just, they're SQL queries. So it wasn't a big lift. I really think, if you need a database and you need streaming OLAP, this is just a great choice, right?
Okay, cool. And I think also you integrate like nets in the system. I guess you share the same passion with us, that is everything should be easy to deploy, very efficient, and in the open source way, right? The open source license. And I guess compared to Kafka, nets is much smaller binary, also feature rich. And can you share a little more about how you use nets?
Yeah,
is that
sure.
something today integrates Timeplus in your system?
Yeah, good question. So I think a lot of Timeplus users hear about Timeplus and Kafka, and that's a great use case. For us, it didn't really, we couldn't figure out a way to get Kafka to run in constrained environments on the edge and kind of low maintenance. So we found an alternative, Nats Jetstream, another open source project, and that's really essential to what we're doing as Timeplus. So that's our piece that we use to scale, really almost infinitely, right? Like we can send all this data to these message brokers. We can use it as a buffering tool from the edge to the core. So if we lose connectivity in the edge, we've got Nats. Nats can just sit there at the durable, message broker, KV, and a few other things. And Nats is our, is like a free buffer that we get, right? So you've got your NAT server on the edge and the core. If they become disconnected, they'll reconnect and send all the data up to the cloud. So we really like it.
Thanks much. Yeah, again, it's so amazing to see you are building open source software for that particular network monitoring and the security domain using Timeplus as the other building block in your open source. So everything is open source H2O, and it's up to the user how to deploy them, whether they want to deploy by themselves or using a central hosting service. But the choice is on the customer side. And you mentioned the migration effort from the SQLite to Timeplus is so easy, and you can also leverage the streaming capability, not just do a regular batch, but in the future, you might have some real-time or streaming alerts or some visualization. So everything is so awesome. And no matter you prefer using Kafka or Nets, I guess Timeplus is working on this real-time domain, and we really embrace all the real-time data sources and the systems. Yes, thank you so much for sharing. And I guess if anyone have any questions, feel free to leave in the comment, and we can have a few more minutes in the end to answer. Again, thank you so much for Michael for the great sharing. Yeah.
Thanks, everybody.
Yeah, and maybe hand over to Ken. You also have some amazing story regarding telemetry observability, right? So go ahead, please, to share the screen.
Thank you, Mike. What a beautiful story. So I really love the principle, a single binary. So single binary for everything, like for Nets, for Timeplus, all of the stuff should be simple. So yeah, we cannot tolerate a big, very complex setup for sure. So today, I like to demo some of the very critical use cases in production. One of them will be the high cardinality OpenTelemetry trace data analytic. So trace data is basically comes the nature with the high cardinality, because there will be a lot of microservice and a core chain. And also user like to identify the outlier of the traces in real time. So it turns out this is a very typical problem in production. So for lots of companies, they are basically spending millions of data to analyze this kind of trace data. So why it is so difficult? Because trace data is happening so frequently. Assuming you have a very busy data infrastructure, you have a lot of microservice. And the user basically do a lot of RP requests per second. There will be a lot of trace. Because the microservice call microservice and call microservice, and there will be a lot of traces, a lot of data, and it's very expensive to index all the trace data. Why? Because most of the time people do not care about the traces. Regular traces people do not really care about. What they care about is basically the outliers. So most of the data infrastructure or product, they have the latency SLA. For example, when a trace, for example, has violated the SLA, user really like to dig out what happened. But the indexing of the trace is meaningless. So, and also the second problem is it's very dumb to continuously pull the traces, especially when the traces has a very high cardinality. So in order to find the outlier traces in regular database, for example, user need to for 5 seconds, every 5 seconds, for example, to pull. If there's any outlier traces with high latency, if there's any outlier traces with high latency, for example, repeat this kind of query again and again. It's really inefficient and really expensive. So I have seen a lot of customers, basically they have put in this kind of high latency traces against the Splunk, against the Open Search, against the Elasticsearch. That literally bring down the whole system. Very super expensive. And also, it is very slow and very expensive to reconstruct the traces. For example, one of the traces basically usually have different spans. Each of the span represent a microservice. How much time it take for that service specifically. And in order to get the full trace, you need to group the traces, different spans according to the same trace ID to form a full trace event and analyze if there's outliers. Every single time you need to reconstruct the traces, which is very expensive. So Timeplus had a unique way to resolve this kind of challenges. So number one, what about if we can group the traces, group the spans in the traces automatically, and automatically for you. And the user basically query one trace ID, and you automatically have all the spans in that trace. That would be super convenient. You do not need to reconstruct the traces every single time for your ad hoc query. And what about if during the grouping of the traces, what about if we can detect the high latency traces automatically for you? Whenever the traces violate your SLA threshold, we can just emit these traces to you, and the user basically get what you like to get in real time. And for all of the traces, the regular traces, the user do not really care about, and they can basically send the data to send all these kind of regular traces to maybe an S3 bucket or a Apache Iceberg for compliance and auditing or infrequent access purpose. And also we can, after we detect this kind of high latency traces, we can send these high latency traces to a downstream token system like a Splunk, like a ClickHouse, to save millions of dollars, save lots of costs, storage costs and operation costs for sure. So how Timeplus basically resolve this problem? So this is the SQL, which is doing all of the heavy lifting stuff. This SQL looks like a very regular SQL, for example. We can just select from the alter traces, for example, and we can do the shuffle by trace ID. Shuffle by trace ID, for example, you have a lot of partition of data, and you like to group the data from the same trace into the trace events, and then we can group by the trace ID. Group by the trace ID is basically a group of the spans in that trace to form a full trace event, full trace analysis event. So we can group array of the span event to form a complete trace event, and we can analyze the span of the traces, calculate the traces. this is kind of a SQL statement. It look like a very traditional regular group and aggregation. But the secret source is basically the emit clause. Emit clause is defining different things. Number one, for all of the traces, each of the traces, we need to keep tracking the trace regarding the expiration. So, and the expiration is defined by a timestamp. This is basically to identify the timestamp. User can use the default timestamp using TP time, or choose a different timestamp. And also we have defined the max span of the trace. Max span of the trace is basically typically represent the SLA. For example, for all the traces which expand, which is greater than the trace span greater than 500 milliseconds, and emit that defines ASLA. That defines outliers. So every single time there's a event, there's a trace which this kind of threshold, we can emit to the end user. And also we have a timeout 2 seconds, for example. So this is defines when we can see a trace is basically complete. Some of the traces may take more time to complete because of the latency, because of the the data collecting pipeline or data indexing pipeline. And also even some of the traces may synchronous, that may take some time. So we can define a timeout here. So most of the traces will be timed out. So some of the traces will be basically violate the threshold, the SLA threshold. There's another keyword, which is only. The only is the very important. It turns out a very important difference. Only means that we can emit all of the traces, all of the traces to the end user, to group them together and send all of the traces, group the traces to the end user, or user have a way to just specify, I don't care about all of the regular traces, just tell me, just emit the traces which has violated the max span, which is 500 milliseconds in this case. That will reduce lots of data. Assume you have millions of events per second, hundreds of thousands of traces per second in your system, and we only emit the traces which violate the SLA threshold. That will be greatly reduce the data volumes in your system. Your user only get the violation. They only get the traces which violate the SLA. So we will demo this a little bit in the next demo. So how it works internally? So since that the open tracing may have a lot of trace IDs. Keeping all of them in memory is super expensive sometimes. And also in order to tracking all the traces, we basically introduced the hybrid Hashi table. We can group that by the trace ID. For each of the trace ID, we can internally we need to check in the span of the trace, and also we need to have different aggregation like the timestamp, and also we like to group all of the message, group all of the spans to form a complete trace. So all this can consume a significant amount of memory by considering there's a lot of concurrent traces happening in the system. So we introduced the hybrid Hashi table, and for the hot traces we can use the pure in-memory part to check in the hot traces. But some of the asynchronous traces, for example, they may take several minutes even or hours to close the traces. For this kind of traces, we can spare on the disk if the memory is not enough. So in the meanwhile, we have another data structure, which is a hybrid sorted map, which is basically checking the trace ID's life cycle for the timeouts. Similar idea, but in general, we are introducing the hybrid Hashi table and the hybrid sorted map to tracking the traces, high cardinality traces, high frequently updated traces, and the user do not need to worry about the memory utilization and also the cardinality of the data. So And in this demo, I would like to demo one use cases, which is basically sending the traces to the downstream Splunk. So how the our workflow is basically I have a data generation tool, which is generating the OpenTelemetry traces and spans. And that trace is basically ingested to Timeplus directly. And Timeplus basically run the query, which is shown on the previous slides. And also either grouping the spans into traces to form a complete traces and then sending to Splunk. Or we can detect the outliers and sending the data to Splunk. That would be reduced a lot of the data volume to Splunk, because Splunk is basically like charged by data volume. If you index all of the traces to Splunk, that would be lots of money, cost lots of money. And also you have the capability to sending the data, sending all of the traces, 4 traces to S3 bucket and also Apache Iceberg, because they are using the cloud storage for auditing and compliance and slow ad hoc query purpose. So I'll start the Timeplus server, and I'll use the Timeplus client to attach the server. This basically we are clean environment, and we like to run the small EPS data generation for the telemetry data. We can take a look at what it looks like for the trace spans. Each of the trace spans has a trace ID, unique ID, and a span ID, very typical, defined by the OpenTelemetry protocol, a standard basically. And the parent span ID has a name. Name is basically microservice, what it does, and the start time and end time timestamp. And also have different attributes like service name, components, what kind of HTTP method is going to hit, and also HTTP URL. So first of all, I would like to group them together, because each of the microservices basically sending their own spans. We need to group them together for a complete trace. Group the spans into trace events, and we also like to calculate this trace span, basically the latency. So after the grouping, we can see we have only one event for one trace. One trace can have different span, which is an array in this example. So we can create a Splunk XML stream. Basically, we like to send in the data to Splunk. Create this XML stream, Splunk XML stream, and create a materialized view. The materialized view basically doing the computation, grouping the trace spans into trace and sending the data to Splunk. Everything else is basically the query. And we go back to Splunk, do the real-time search, 1 minute, the recent 1 minute window. So from the Splunk, we can see we have the traces, which include the different spans, start timestamp and the span, the trace ID. Double-click the trace event, which include different spans. Each of the span have the span ID and also start timestamp and also what it does, and the microservice name, for example. And this is for the small events, doing the grouping. And next stuff, I like to emulate the big high-cardinality traces. I'd like to drop this grouping material first, because otherwise it will blow my Splunk license very, very easily. So we like to, in this case, we have 1.7, 1.8 million events per second. And we like to group, first of all, we like to detect the outliers. Outliers is defined by the max span 500 milliseconds, group the same trace ID and identify only is the keyword, which is very important here, because we only care about the traces which violate the max span. Same thing, but the events only contains the traces which violate the 500 milliseconds latency SLA. Here we have span like 800 milliseconds, for example, and the trace event is same thing. Group them together, group different span into different in the trace events. Here we can see we can analyze more than 1 million event per second in this case. And how many concurrent trace in this window in 1 second, every single second? This is basically like 300,000 concurrent session and a lot more than 1 million concurrent EPS per second. We like to create the materialized view and also only sending the outliers, trace outliers into Splunk. Let's go back to Splunk and take a look. Splunk here, we do the real-time search. So we have the outliers, the span, which is more than 500 milliseconds. All of the 500 milliseconds are basically indexed into Splunk. All of the other regular traces, basically we discuss them. Of course, we can option indexing all of the regular traces into S3 bucket, for example. So in this case, we can see the payment. The payment actually takes more than 600 milliseconds in this case. Super easy to identify which microservice basically has the outliers. So we can create alerts as well in Timeplus in real time, and also they can trigger different kind of actions, sending an email and run a script, which is pretty handy. So in this case, we basically we have already doing the outlier detection for you, indexing to Splunk, and you can just consume the results, which is reduce a lot of Splunk data license volumes, which is very, very powerful in this high cardinality, high frequent trace analysis scenario.
Yeah, this is very, very impressive, right? Millions of events every second, and not just doing the filtering by HTTP status code, it is actually aggregated by the span, whether it's over half second. Yeah, that's very sophisticated and really save a lot of cost on the Splunk side.
Yeah, exactly. So we have more exciting things in this month for the v2.9 updates. So as usual, we have in last April, we have quite a lot of different updates like pipeline, schema evolution of the mutable stream, and also have the native JSON support, the data queue, and also HTTP sync. We just demoed sending data to Splunk, and also we can send the data to Elasticsearch as well. So in May, we have even more things to update. So number one, we have the just-in-time streaming processing for big performance and efficiency improvement. That is super. So in query processing, you can do SMAD, SIMD, and also you have the JIT. So for streaming query processing is basically really beneficial to streaming query processing for JIT because it just compile once and reuse forever. It's just like streaming query processing is always up and running. We have some of the numbers to share to you regarding the performance improvements. We have the parameterized view, which is very super easy for the dashboarding, and also mutable stream TTL, more enhancement, which is a long request from our customers. And high cardinality sectionization, we just demoed. Distributed log is a very good thing. I like to update a little bit how we use the logs, distributed log stream and log stream to analyze the log without any indexing. Also, JSON encode and cast, JSON cast function to convert JSON to string, JSON object to string, and also convert the JSON string to object, which is very, very convenient. Even in my demo, we are using the JSON encode to encode the whole row and sending the data to Splunk in the JSON way. Python UDF for ARM, which is also long request by Timeplus user. By the way, in this month we also GA Timeplus Enterprise v2.8. Next month, as usual, we have the alert support. We have the schedule, task, and the job. User can create, create tasks in Timeplus. The task can run a Python script, for example, and do whatever you like to do. Very, very powerful. And also we have enhanced distributed query processing in large cluster and materials view, rebalancing, affinity, And also the most important part is basically we are continuously improve the system performance and efficiency. And we would like to make Timeplus is really simple and performant and efficient in one single binary. So the first thing is like just in time stream query processing. So assume we have expression A plus B multiply C and also plus 5. For this typical expression, how Timeplus evaluate during runtime evaluate this expression is based on the left-hand side. We call it interpreting execution DAG. So we just like form a tree, and we execute according to the tree. So for example, we first do the B multiplies C, and after the multiply, we move up the tree and then do another A plus the B multiply 3 result. And again, after doing that, we do another plus 5. This is called interpret execution, because every single time we move up the tree and after we interpret all of the tree, the DAG, basically we get the results. It turns out this is not quite efficient. Even we have enabled SIMD, SIMD optimization. So for the JIT, which is different, just-in-time compilation is basically, I like to compile the whole DAG in one DAG, just using one. Everything is evaluated in one DAG, just in one DAG, only once. So which is basically I can evaluate the whole expression just using one node. That's all. It's done. We do not need to move up the tree, move up the DAG, and do the interpreted execution one by one, which turns out very efficient for this kind of operation by using just-in-time compilation. So, and regarding the support right now, we support the binary operators like plus, minus, multiply, XOR, and also unary operators, absolute function, and also some of the logic function, and also conditional function, and the bit shift function. So all this stuff basically can be JIT compilation enabled out of box. User do not need to pay anything. Automatically, when they use this stuff, the whole performance and efficiency get improved automatically for you. So we have some of the tests regarding the performance improvements. So for example, for the first query without JIT, which is like 161 seconds, we do a big amount of large testing. So we have the difference, which is like 25 performance improvement. The second one, which is basically the arithmetic operation, like plus and multiply, because we can fuse them together and do all of the computation in one go, and we have like 100% the performance improvements. And the third one and the last one will be a little bit more typical, like if you do some of the if conditions. And also, if we like to do the max aggregation, mean aggregation, so we have 48% in performance improvements, and also almost 20% performance improvements. That's big. That's really big performance improvements out of box for our users, which is super great. So parameterized view, so user can do using some of the placeholders we call, for example, in this we can create a view, and there will be two placeholders for the predicates from time to time and date time 64. And during select, you can pass the parameters to the view, and they basically can interpret this parameters automatically, replace this parameters automatically for you when running the view. This is very convenient for the dashboarding. You have a drop down and you can pick different parameters at the runtime. Mutable stream enhancement. The TTL is a very long time request by our Timeplus users and customers. So right now, user can create a mutable stream, and they can set up a TTL seconds, and you can do the insert because the TTL is basically happening in a synchronous way, and the user right now can do some of the optimized stream, mutable stream, if they like to do aggressively to prune the data by the TTL. They can do the optimization of the stream if they like. But most of the time, TTL will kick in a synchronous way and will do the work. And also the secondary index maintenance, user can drop index right now. For example, user create a bad index. They don't need that anymore. They can drop the index. Secondary index. UUID as a primary key and secondary key right now is supported in mutable stream. This is one of my favorite because this is essentially my go-to tool to analyze Timeplus DIX. For example, user has some of the problem, they send the log to us, and we can, using the external log stream, to analyze the log automatically, analyze your file without any indexing, automatically and out of box. So create the external stream, and we can define some of the rules, like extracting the log timestamp, extracting the log level, just a regex, and also the last one will be very important is the row delimiter. So like how to break the line, break the logs into meaningful segments or meaningful log record. For example, you have a stack trace. You do not want to, each of the stack trace, each of the line of the stack trace in different row, in different record. You like to group them together. So this is the line breaker, which can be significant when you analyze your log files. So one example, I use this one to do the aggregate my one of the production issue, for example, in a cluster environment. So I can do really easy to do a Timeplus D logs and set up the create the Excel stream, point to your files or photos, and then do the count, do the aggregation, do the search, do any kind of SQL can support, anything SQL can support, super fast. It's just like in my local environment, it's like 3 million rows per second, 700 megabytes per second. This can be the most of the log analytical data platform like Splunk. You need to index the whole thing, yeah, which is basically violate your data license very, very easily. With Timeplus, you don't need even a license, actually. You don't even have Timeplus enterprise license. You can just, using the binary, point to your file and analyze your logs automatically without any indexing. And you can do any kind of grouping, search, and do everything you like. And also it supports streaming query processing in live environment. This is the distributed log stream comes into play. Assuming you have a big cluster, you have a different nodes, in the cluster, and when something happens in your cluster, you really like to do the real-time troubleshooting. So previously, even in Timeplus cluster, so right now you need to indexing all the data to a Logstash or OpenSearch or Elasticsearch and search from there. But for lots of data, and the user can query the log directly without any kind of indexing, which is super powerful and in a distributed way. So in this diagram, we can see we have different nodes, and different nodes have different log files. We can just create Excel stream point to your file, and then we can select from any kind of node in the cluster. Do the real-time streaming search. It's just like a distributed grab. You can grab the files distributed in your cluster in the whole all of the nodes. You can do the aggregation, do the filtering, do all different correlation. You can do table query, you can do historical query, you can do streaming query. Very, very powerful. Log stream, we have more things to say. So assume you have a lot of logs. Log stream is not necessarily bound to the log file I just showed. It can be any kind of logs. The logs can come from a Kafka topic, a NAS topic, for example. Everything logs. And when logs is basically in the log stream, we can, using Timeplus, we can do the filtering and also deduplication. Deduplication is one very powerful thing. It's like, so if the application has some of the bad code, they basically log in the same logs in a loop, in a busy loop. There will be lots of data. And we can do the deduplication according to message. For example, we can get rid of the timestamp and using the message to the deduplication. That will reduce a lot of data volume as well. So we can do join the log stream to different metadata, for example, node attributes or different lookup to enrich the logs. And after the enrichment, we can do the downsampling aggregation and then send it to Splunk. Lots of data volume reduction, and the user only care about what they really care about, and they discard what they don't want to. That will be save a lot of cost. Lastly, we have the JSON encode, JSON cast. A very super convenient function. This is basically almost my favorite two functions recently. So user when interacting with the third-party system, for example, target system, they have different. Most of them they have the REST JSON format, for example, and the user really like to group them together in the JSON and realize in the JSON. So we can use the JSON encode. JSON encode can take in a variety of parameters, for example, column 1, column 2. You can specify whatever column you like to JSON-ized, JSON file. We can just convert that into a JSON string automatically for you, and you can use that as a payload for the downstream system, for example. And one of the pro tips, which is basically you can specify star as well, and also except you can just I have 30 columns, but I like to exclude some of the columns. So that is the accepted place in the row. Basically exclude the columns you do not want to JSON file. So convert all of the columns by excluding column 1, column 2 to the JSON stream. JSON cast do some of the other thing, which is yeah, you have different columns and you can cast them into a JSON type of object. And same thing, we can do the JSON cast, and also by excluding some of the columns you don't want to convert. All right, this is all from me. Pretty much everything. Thank you.
Yeah. Thank you, Ken. It's great to see all those awesome features, and you can see that it's not Timeplus not just run fast, but also one of our secret sauce is we can deliver features and solve real customer issues in a super agile way, right? There are so many features every month, every week, and many of them will be available in the Timeplus Proton, and we welcome all the features, all the feedback. Yeah, now because we are almost at the end of the webinar, and we can take some questions. And Michael, you are also a Timeplus users, right? So do you have any questions or feedback on whatever you see today?
Yeah, I think what's really interesting, like in the Timeplus trace analysis slide, what you didn't show is how difficult it would be to do that without Timeplus, right? Like what are the other systems that you could think of that you would have needed to, for me, I think off the top of my head, a different, serious database, a message broker, and Apache Flink or something like that, right? And we're talking about like a whole large system.
Yeah, and you have to send those documents or JSON documents into system. It's usually like thousands of lines and a very complex structure, and you are wasting a lot of kind of both network traffic and also storage computing resources by storing all those law events. And the Timeplus can apply those data extraction and apply the joining, anomaly detection, and figure out as a camp demonstrated, we can send out those notable events into the downstream and leverage your existing tool to do the on-call on the troubleshooting. But you don't have to send all those healthy or normal data into the system, right? Otherwise, too many. It's not the best use of your Splunk license.
Yeah. Being able to do the ETL in Timeplus itself is huge. Like we'll be doing the deduplication right in SQL instead of outside of that. So that's really cool for us.
Cool.
Thank you. Yeah.
So yeah, again, we might have a few more questions, but we run a little bit over time. But again, all those great content will be available, and we will share as either blog or video. And you can always ask more questions in our community Slack. And just like Michael shared, that it's very easy to integrate your existing code with Timeplus, no matter you are building a product or try to upgrade or simplify your data stack. And you can start from Timeplus Proton and our Timeplus Enterprise also in a very agile way to iterate. You can always download our GA version, preview version, and you can try this on your locally, and always give us feedback and help us to grow and to support more use cases. And we will have a webinar almost same time, similar time next month. And looking forward to see all of you there and give us more support, and let's make data processing much more agile and don't have to go over set up a very complex system, as Michael mentioned, that is go simple, go efficient, go cost saving. Yep.
Simple wins.
Yeah, simple
Thanks so
wins.
much.
Thank you.
Yeah,
Thank
thank
you.
everyone. Yeah, enjoy the
Thank
day.
you.
Thanks so much. Goodbye.
Thank you. Bye.
Bye.